How much do Americans spend on Disney World vacation? This is a practical example to show you how you can use normal distribution to compute probabilities. So data shows families on average spend $5,300 on a Disney World vacation. Assume that the amount spent is normally distributed with a standard deviation of 2250. What is the probability of family expenses on such vacation? A being less than $4,000. Okay, so since we are assuming that it is normally distributed, the question that we have in part A is what is the probability that the amount to spend, say random variable x, which we are saying random variable x, which is the expense, is normally distributed with mu or mean of 5,300 and with sigma square or variance of 2250 to the power 2. So this is what we usually refer to in the sense of normally distribution with a mean of mu and variance of sigma square. Okay, so for this random variable in part A, we are interested to know what is the chance that its value is less than 4,000. Which, if we use standard normal distribution or standard normal random variable, it means the probability of z, the standard normal random variable, is less than 4,000 minus the mu is 5,300 divided by the standard deviation 2250. So if we compute this, the best way to do is just to show you on this plot of on this graph of PDF or probability distribution function for, say, the standard normal random variable. Just for this one, let me just quickly compute. So it is 4,000 minus 5,300 divided by 2250. We get point minus or negative 0.578. So what we get is we are interested to know what is the chance that z is less than negative 0.57, roughly 8. Okay, so that's the question. Which that means this, so about roughly half a sigma to the left of mu. So this point is mu, and we are talking about roughly this point. So if I want to illustrate it for you on this graph or plot of PDF, we are talking about, I'm deviating, but we are talking about roughly this point. And since it is asking what is the chance that z is less than this point, it means what is the chance that area under this normally distributed variable, random variable, what is the area for this black shaded portion of the curve? To do that, the best thing is to use either the available table in textbooks or go with just Excel function. So here I am showing you the Excel function, how to use it. The best way is just use Excel insert function and use the normally distributed random variable. So you can enter x. In this case, we were interested in x 4,000, mean of 5,300, standard deviation of 2250, and then cumulative. Yes, I want to find the area corresponding to the area under the curve less than a value, or basically the CDF. So in this case, the answer is true. There you go, 0.2817. That's the number. So I'm gonna just copy this number and paste it here. Okay, so that's the answer. Now, you could use also the z values here. In that case, negative 0.578. If I just go back to my Excel sheet. So over here, if I just, instead of saying 4,000, let me just copy paste this function. So for example, say I copy paste this function here, and now the number is negative point, I think it was 578. If I'm doing this, I'm using a standard normally distributed random variable, so uh, the mean is 0 and the standard deviation is 1. There you go, roughly the same value. So I'm saying we could use either the originally given values or just the converted um, or uh, the modified standard normal random variable. Now going back to the question here, so we have the answer for part A. What about the answer for part B? What is part B? So in part B, we are saying what is the chance that the family expense on a Disney World vacation is $6,000 or more. So in part B, what we are doing is we want to compute probability that the X value is greater than or equal $6,000. Okay, so this is of course 1 minus probability that, okay, 1 minus probability that X or expense is less than 6,000. Great, that's our CDF. So 1 minus, same as above, you could say Z transformation from normal random variable to standard normal random variable. So less than 6,000 minus 5,300 divide by standard deviation 2250. The reason we do this transformation is because the tables available, standard tables in textbook, are all for standard normal random variable. So you need this conversion. But if you're using Excel, this is not necessary. So I am going to, from now on, use Excel. So in this scenario, for this part, uh, so we are interested in 6,000. So if I go back here, this time I am interested in finding 6,000, same mean and standard deviation. So it's 0.6221. 0.6221. Going back to, okay, so we are dealing with 1 minus 0.6221, and that is 0.3779. So roughly this means there is 37.79% chance that the family expense is going to be greater than or equal $6,000 on this Disney vacation trip. Okay, so part C, what is the probability that the family expenses on Disney World vacation will be between 500 and 1,000? Okay, so this time we are saying what is the chance that X is between 500 and less than, is a greater than 500, less than 1,000. So uh, in that case, we can do just this. We can say this is as if we are saying the probability that X or expenses is less than 1,000 minus the probability that expenses less than 500. So each of them are CDF. Each of them is just computed by using the CDF. So you can again do the transformation or conversion of the normal random variable to standard normal random variable. But let's avoid doing that now that we are using Excel. So 1,500. I'm going back to my Excel sheet. So this time I am doing, uh, let's say, let me go back to example. So instead of 500 and let's stick with this 500 and 1,000. So in this case, what I have is 1000. So it's very, probability is very low, 0.0, roughly 28. So let's have that. Okay. And if I copy paste the same thing here, and this time 500, so it's even lower, of course. Now, if I subtract these two numbers, this number minus this number, what I get is 0.0115. So that's the number I'm going to use. So if I go back to, okay, so the answer is 0.0115. So what this means is there is roughly 1.15% chance that the family expense on this trip is going to be between 500 to 1000, pretty low. Okay, so the next question, part D, is what would the expenses have to be for the 5% of the families with the most expensive Disney World vacation? So in this scenario, it's going to be the reverse process. So I'm going to show it um, here. So as if you're saying, imagine I am interested to know, um, let me just clean this up. Okay, so as if I am saying, okay, as if I am saying, what is the chance, or not the chance, what is the expense value above which, okay, so this point, what is this point such that above that the area under um, the curve will be 5%. That represents 5% of families. So in order to use CDF, or cumulative distribution function values, I need to focus on not the right side of this line. I need to focus on the left side of this line. Basically, I need to first compute area under the curve on the left side, which is the CDF. So if the right side area is 5%, the left side area is 95%. So for part B, what I need to first compute is um, compute the expense that I know, okay, such that expenses below that value has a chance of 95% or 0.95. That's what I'm trying to figure out. To do that, the best thing is just to use, again, Excel. If you are going to use a standard table in textbook, then you need to do the conversion. You need to first use those tables to figure out the standard normal random value, random variable value. Then from there, you go and convert it to X here. But in this case, let me show you using Excel. So if we use Excel here, what I need to do is I need to use inverse function. There you go, norm.inverse. What happens is I am interested in probability of 0.95. My mean is same as before, $5,300. Standard deviation is same as before, 2250. There you go. So it's roughly $9,000, approximately. So the answer is, again, it's like this: norm.inverse, probability 0.95, mean of 5,300, and the standard deviation 2250. There are three arguments for this inverse function in Excel. So if I do that, then if I go back to my uh, calculation sheet, so the answer here is x should be less than, doesn't matter, less than or equal $9,000. So as far as x less than $9,000, then you get 0.95. It means the answer to part B, what would be the expenses B? It would be 5% of families are spending more than $9,000 on a Disney World vacation. That's the meaning of it. If you wanted to use the standard table at the end of textbook, it's as if when you go to use the table, let me go back to my Excel sheet. Okay, it's as if when you go back to table, you would just use a standard normal random variable. For that, the mean is 0 and the standard deviation is 1. If you do that, it reports back to you 1.6448, roughly 1.6449. Okay, so what I'm going to do is then I am going to use this 1.644 and I do the conversion in the sense that uh, I am saying x minus mean. I'm just writing the formula here for you. So x minus mean, okay, effectively divide by sigma, which is the standard deviation, or divide by standard deviation, is this value. I have the mean, I have the standard deviation, I need to find x. That's what I'm doing. So I just need to multiply 1.6, this value, 1.6448, times the standard deviation plus mean. That's what I need to do. So equal to this value times 2250 standard deviation plus the mean, 5300. There you go. So 9,092, that's roughly same value as I computed the other way, using just directly using the inverse function for normal distribution in Excel. Okay, so all I wanted to highlight is if you use tables from the textbook, you would end up with a z-value 1.6449 roughly, and then when you use that in the uh, conversion process, you get back to your $9,000 that we computed here. Okay, that concludes this example, and hopefully it's a good illustration of how you can use Excel function and also normal distribution to compute probabilities.